Hi everyone. I think we'll just wait for a couple of minutes to let everyone in. Um, hi everyone. Thank you for joining us today, and welcome to our webinar. Following a study that we have completed, we'll just be sharing our findings on transporting hydrogen across BC, looking at opportunities, risks, and infrastructure needs, with a focus on hydrogen carriers. So we're really pleased to be working with the BC Ministry of Energy and Climate Solutions and the Clean Energy and Major Projects Office on this initiative. We're also really pleased to be completing the report and research with our partners at Sacra Davy. This is just the agenda for the webinar today. We will start with a 5-minute introduction, providing kind of a brief overview of the work that's been done to date and some background to the study. We'll then provide an overview of hydrogen transportation challenges and discuss the hydrogen carriers that we included in the study. We'll then look at the infrastructure requirements for transporting hydrogen and hydrogen carriers, focusing on pipeline, railway, and highways, and looking at some of the existing infrastructure within BC. I'll then go on to kind of an overview of the key health and safety risks and considerations, and then we'll share the key opportunities and recommendations that have come out of our report. And finally, we'll have around 15 to 20 minutes for Q&A with our technical specialist partners at Sacra Davy. And in terms of the Q&A, please just add any questions that you have to the Q&A box, and we will respond to these during the allocated time at the end of the webinar. So before we get started, I would like to note with gratitude and respect that we acknowledge that the lands on which Foresight operates are the traditional, ancestral and unceded territories of the First Nations, Inuit and Métis people. And I am personally joining you from the unceded shared territory of the Squamish Nation and Lil'wat Nation. This slide just provides a bit of background to Foresight. Foresight is Canada's largest clean tech network, and our purpose is to help the world do more with less in a sustainable way. Our mission is to connect industry with the world's best clean tech solutions, and we support both the supply and demand sides of clean tech in Canada and work across many sectors, with hydrogen being one of our growing areas of focus. And we've supported 1,370 clean tech companies across the country. We have a network of over 250 clean tech EIRs and mentors, and we have a network of 400 private capital partners, 1,500 national and global partners, and a community of 15,000 members, and have curated over 25,000 climate connections. So we'll just start by providing a brief background of this project and overview of our work with SEMPO to date. So in 2021, the BC Hydrogen Strategy was released, which is a comprehensive framework aimed at supporting the province's transition to a clean hydrogen economy. One of the targets of the strategy is for BC to become a world-leading hydrogen economy by 2050. And the hydrogen strategy also highlighted a regional hydrogen hub model to overcome the challenge of matching hydrogen demand with supply. So the hub model looks at co-locating hydrogen production and end-use applications. And SEMPO has been working with Foresight to complete an opportunities assessment, exploring the development of regional hydrogen hubs in key economic areas. So the study has been focused on regions where project development is underway and potential sources of demand exist. And the Lower Mainland report is complete and available online. The BC assessment is in progress and will be released in January, and Interior and Vancouver Island reports will be completed next year. It's also worth noting that the City of Prince George and the City of Prince Rupert are exploring the development of a northern BC hydrogen hub through opportunity assessments in each respective region. So to support successful hydrogen production and use across the province, a key challenge was identified in ensuring efficient, sustainable and safe hydrogen transportation. So we have undertaken this study that examines the opportunities and risks of transporting hydrogen in BC, and again, in particular via hydrogen carriers. So this webinar just provides a brief overview of our findings, and the report will be publicly available later this month. So what is hydrogen? We have previously held Hydrogen 101 webinars as part of the Hydrogen Hub's work, which are available online and go into more detail about what hydrogen is and the potential role for hydrogen in BC. So this is just a brief overview in the essence of time, but if you would like more information, please do check out those previous webinars. So hydrogen is an abundant molecule that is commonly used today as a component of various industrial processes, including refining petroleum products, metal production, chemicals, fertilizers, and processing. Hydrogen is also a versatile energy carrier that can be used to store, move, and deliver energy. And it requires an input of energy to produce it and then can be used as a low carbon fuel for various applications when it's been produced in a sustainable way, for example, by electrolysis or steam methane reforming with carbon capture. Low carbon hydrogen can then be used to support decarbonisation in hard to abate sectors such as heavy duty transportation and in industrial applications. So what are the main challenges with transporting hydrogen? So pure hydrogen can be transported as a gas or a liquid. However, there are advantages and trade-offs with both of these options. Hydrogen is a gas at standard temperature and pressure, but due to its low volumetric density, transporting large volumes of hydrogen as a gas can be inefficient. Gaseous hydrogen also needs to be transported under high pressures in specialized tankers. Transporting hydrogen as a liquid is much more efficient for transporting large volumes, as liquid hydrogen has a higher energy density by mass compared to gaseous hydrogen. So this means that more hydrogen can be transported in a given volume in its liquid form. But to liquefy hydrogen, it needs to be cooled to minus 253 degrees centigrade. And this process is very energy intensive and expensive. So liquid hydrogen also needs to be stored and transported in specialized super insulated cryogenic tank storage, which can also be costly. In addition to this, hydrogen is also odorless, colorless, and highly flammable. So there can be explosion risks if it's not handled appropriately. And this means that stringent safety measures are required during storage and transportation of pure hydrogen. And in some cases, instrumentation may be required to detect hydrogen gas in the event of a spill or a leak, which is another additional challenge for handling hydrogen. So the advantage of transporting pure hydrogen is that no additional conversion processes would be required before or after transportation. So in the study, we looked at 3 different hydrogen carriers or compound forms of hydrogen that can facilitate efficient storage and transportation of hydrogen, but allow for simpler handling. So we looked at ammonia, methanol, and liquid organic hydrogen carriers, or LOHC. And this slide just provides an overview of some of their key properties and differences. So ammonia is an inorganic compound of nitrogen and hydrogen that exists as a gas at room temperature. Anhydrous ammonia is in its pure form as a gas must be compressed under high pressure or at low temperature to be converted into a liquid. And aqueous ammonia is prepared by dissolving ammonia in water. So for ease of transportation, hydrogen transportation over long distances, anhydrous ammonia is predominantly used in its liquid state. So compared to hydrogen, the liquefaction process is much less energy intensive as less cooling is required to around minus 33 degrees centigrade rather than minus 253 with liquid hydrogen. Ammonia is also commonly used as an agricultural fertilizer and in existing industrial processes. And it is stored in and transported in pressurized, semi-refrigerated or low temperature containers. Ammonia is able to store and transport large quantities of hydrogen, so this makes it stand out as a really efficient hydrogen carrier. And although ammonia is less flammable than hydrogen, it is toxic and does have the potential to cause damage to the environment and human health if released or ingested. So this requires stringent management and handling processes. But again, as it's kind of widely used, these processes are relatively well established. Methanol is a simple alcohol that is liquid under standard pressures, standard conditions, and it is widely used in industry as a solvent, antifreeze, and in the production of other chemicals. There's also growing interest in methanol at the moment as a low carbon alternative to traditional fuels, particularly in the maritime and shipping sector, which is again applicable to areas in BC where there are major ports, for example, Vancouver and Prince Rupert. Methanol is also liquid at standard temperatures. So unlike pure hydrogen and ammonia, it doesn't require those high pressure or low temperatures for efficient storage and transportation, and is generally stored and transported in a similar way to gasoline. The production process of methanol is already well established and commercially available. However, traditional production methods can be carbon intensive, which can contradict the goal of prioritizing sustainable energy solutions. So biomethanol and e-methanol production techniques are more favorable to reduce the carbon intensity of production. Liquid organic hydrogen carriers are a group of compounds that absorb hydrogen as liquids upon contact and can release hydrogen at a later stage, facilitated by chemical reactions. So there are several different LOHC, but in the study we largely focused on methyl cyclohexane, or MCH. LOHC are relatively simple to transport and store, as they have similar properties to crude oil-based liquids like diesel or gasoline, and they can be transported as such. They've also been shown to be relatively inexpensive and capable of handling large amounts of hydrogen. However, the dehydrogenation can be, again, energy intensive and is not yet kind of fully established on a commercial scale. So the report does go into further detail on storage requirements and the different characteristics and safety precautions for each carrier. And again, there are disadvantages and advantages to each option, and consideration needs to be given to kind of those additional costs and carbon emissions associated with the conversion processes. So there are existing regulations that govern the transportation of hydrogen and hydrogen carriers in BC. And here we'll just provide an overview of some of the key regulations. So the Transportation of Dangerous Goods Act and the Transportation of Dangerous Goods regulations were established in Canada to promote the safety and security of people, property, and the environment during the transportation of dangerous goods via road, rail, air, and water. So this also includes hydrogen and hydrogen carriers, including ammonia, methanol, and LOHC. The Transportation of Dangerous Goods Act provides a regulatory framework, while the regulations outline more detailed requirements developed under the authority of the Act. So including specific requirements for classification, handling, and documentation of the dangerous goods. The Act also mandates that an emergency response action plan is produced when transporting hydrogen and hydrogen carriers, depending on quantities. And in 2022, the BC Energy Regulator's oversight was expanded to include pipelines, facilities, and related activities involving hydrogen, ammonia, and methanol. BCER are also currently undertaking a review of the regulatory framework to accommodate emerging technologies and processes in hydrogen production and transportation. So this area of kind of regulation is evolving. And we also do, again, mention additional applicable regulations and acts in the final report. So next we'll move on to the infrastructure section. So generally hydrogen and hydrogen carriers can be transported in three modalities. So via pipeline, highway or truck, and railway. So this section just provides a brief overview of some of the key advantages and challenges for these options and an overview of existing infrastructure in the province. So pipelines are effective for transporting large volumes over long distances, and this can be a cost-effective long-term solution, particularly if natural gas pipelines can be repurposed. So as shown by this map, BC has strong existing pipeline infrastructure, particularly in the south and northeast of the province. So the map shows existing gas transmission pipelines. And this is particularly focused on areas where there's kind of larger populations or natural oil and gas reserves. Pipelines are also considered to have a lower safety risk compared to truck and rail transportation. But in terms of challenges, pipeline suitability and adaptability is a key consideration when using existing pipeline infrastructure. So particularly when transporting pure hydrogen or hydrogen blended with natural gas, the technical state and materials of each pipeline needs to be considered on a case-by-case basis. And there may be a risk of hydrogen embrittlement or pipeline failure in certain scenarios. Fortis BC is currently conducting a hydrogen blending study looking at the feasibility of integrating blended hydrogen into the network. And the study is also looking at kind of the percentage of hydrogen that can be safely transported through the existing gas pipeline infrastructure. Hydrogen carriers can also be transported by pipeline, but again, engineering assessments would be required to understand the suitability and adaptability. And in terms of construction of new pipeline, challenges include environmental and social impacts, which would need to be assessed and mitigated. The range of impacts, again, would kind of depend on the location and scale of infrastructure upgrades or construction. And finally, the cost of construction of new pipeline infrastructure and also major upgrades to existing infrastructure would need to be a key consideration. So ensuring that there is adequate demand to offset these costs. So in summary, the potential upgrades to pipelines and demand for new infrastructure would need to be determined by different variables such as the form of hydrogen to be transported, mechanical state of pipelines, location production sites, and end-use site locations. In terms of truck transportation, so hydrogen and hydrogen carriers can also be transported by truck, and this is already quite a commonly used approach across North America. Transportation by truck would require minimal upgrades to existing infrastructure. So for gaseous hydrogen, tube trailers are already widely used. For example, HTEC is a BC-based organization developing hydrogen production and distribution solutions, and they use a power cube system to transport gaseous hydrogen. Similarly, liquid transportation by truck is feasible with highly insulated tankers. And again, as mentioned, this is more energy intensive, but can be more efficient for transporting higher volumes. Ammonia is also commonly transported by truck, but requires special safety precautions due to its toxicity. And LOHC and methanol are generally compatible with existing liquid fuel transportation systems. So transportation by truck also has the advantage of extended range to locations where there may not be existing pipeline or railway infrastructure. So in particular, this would be relevant to accessing production and end-use sites. And the map here again shows the numbered highway routes within BC and demonstrates that there is kind of extensive existing infrastructure within the province. But local jurisdictions can determine truck routes and other kind of limitations. In terms of challenges, transportation by truck is inefficient for large volumes, and there are weight and size specifications for vehicles when transporting dangerous goods. There's also the additional consideration for cost and carbon due to the fuel required for each truck movement. But again, this would be variable based on the distance of travel. Some major highway routes within BC are also kind of susceptible to extreme weather events. So we've seen examples of kind of flooding and landslides, and this has the potential to impact supply chains, but also may be kind of a greater risk in certain areas within the province where there's more challenging terrain or greater vulnerability to extreme weather events. So for example, the mountainous interior regions or more remote areas in North BC. Railway transportation, so compared to truck transportation, this is more effective in transporting large volumes, and methanol and ammonia are already transported via railway. So these processes are relatively well established. Similar to truck transportation, rail also allows for hydrogen to be transported in its pure form with pressurized tankers for gaseous hydrogen or insulated tankers for liquid hydrogen. However, one study by the Canadian Standards Association recommended that new standards should be developed and account for the design of hydrogen tender cars. There would also likely be upgrades required to accommodate the transportation of certain dangerous goods. So this would be, again, location specific, so depending on the route and the state of the track. And additional safety modifications and processes, such as training and more regular inspections, would also likely be required. And again, there is some kind of limited availability of existing infrastructure in some areas, as demonstrated by this map. So this shows CN and CP railway lines across BC. And in areas where there is limited infrastructure availability, this might act as a constraint for possible locations where rail transportation of hydrogen is feasible. And the cost of new railway lines would likely be very prohibitive. So to summarize, there are advantages and challenges with each option, and some key considerations for infrastructure upgrades include regional differences, as mentioned. So we can see that there's greater availability of infrastructure in more populous areas and areas with existing industrial or oil and gas industries within BC. So additional infrastructure may be required in certain areas. There would also be variable costs associated with infrastructure upgrades. So again, this is largely dependent on location and the scale of construction or upgrades required. In particular, new pipelines could have a very high upfront cost. There is potential for environmental and social impacts, particularly for new construction or major infrastructure upgrades. And again, depending on the location, this impact would be variable. For some carriers and modalities, specialized containers are required. And in some cases, these are already available. But for example, in the rail transportation, there may be further development and standardization required. And a final key consideration is that there are additional market potential opportunities for hydrogen carriers, such as ammonia and methanol, as they have other industry applications. So particularly, as I mentioned, with the growing interest in e-methanol as a low carbon shipping fuel. So the trade-offs and advantages of each carrier and transportation method would need to be assessed for different scenarios. And factors to be considered again include availability of existing infrastructure, distances, volume demand, end user requirements, and the location of production and end use sites. So handling and transporting hydrogen and hydrogen carriers also involves managing hazards to ensure safety and prevent accidents. So in the study, we highlighted some of the key hazards that may need to be managed when transporting hydrogen and hydrogen carriers within BC. So the first is accidental release due to damaged or defective components. So this would likely be mitigated through operational processes and increased inspections or regular inspections. Adverse weather and environmental factors such as heavy rainfall, snow, flooding, and fog. So this could be mitigated through planning routes and checking weather forecasts, and also having the appropriate equipment to be able to deal with variable conditions. And as mentioned, this can be kind of more of a hazard in certain areas within the province. Earthquakes are also a hazard within BC, particularly along the coast. So new infrastructure needs to comply with specific design standards. Hydrogen, methanol, and ammonia are also flammable under specific conditions. So there can be a risk of fire and explosion when handling these chemicals. And a flammable mixture with air can be formed if there is kind of accidental leakage, possibly as a result of mishandling, mechanical failures, materials compatibility issues, improper maintenance, or collisions. So again, appropriate safety measures can be implemented to ensure that the equipment and piping materials can handle the chemicals under their storage and transportation conditions. Transportation by rail also involves the risk of derailment, so regular preventative maintenance and inspections again can address these problems. Transportation by truck also involves risks inherent to large vehicle transportation, such as road traffic accidents. So to manage this risk, it would be crucial to comply with regulatory standards for vehicle operations and maintenance, implementing safety protocols and training personnel. And then clear signage can also assist with emergency responders and enhance public awareness. And finally, hydrogen embrittlement is a process in which metals, especially high-strength steels, become brittle due to absorption and interaction with hydrogen, causing them to crack or fail under stress. Hydrogen-induced cracking can occur with stress condition cracking, which causes pipeline failure. And these can be managed by appropriate material selection for equipment and piping, adhering to design standards, and adhering to damage prevention programs. So again, processes will need to be clearly defined to understand and address hazards associated with specific transportation options and carriers, and ensuring that appropriate handling processes and storage requirements and procedures are in place to promote safety and limit risks. So this slide just highlights some of the key differences in potential consequences or effects to equipment, property, personnel, and the environment of the different hydrogen and hydrogen carriers. Gaseous or liquid hydrogen can result in fire, explosion, frostbite, asphyxiation in confined spaces, and leakage. Ammonia can result in toxic exposure, fire, explosion, environmental pollution and chemical burns, and methanol and MCH can result in toxic exposure, fire, explosion, and environmental pollution. So this list is not exhaustive. And again, we do kind of discuss other potential hazards and consequences in the main report, but it just provides an overview of some of the key considerations between the different carriers. There's also a risk of chemical leakage with all options, and the environmental risk can be greater with methanol, ammonia, and toluene or MCH, as these substances are toxic. And the risks of hydrogen and various hydrogen carriers are quite difficult to compare and need to consider kind of probability and severity of consequences for different scenarios. And the consequences can vary significantly depending on the incident. So in the study, we reviewed past incidents involving hydrogen and hydrogen carrier transportation, so including causes, consequences, and preventative measures. The incidents ranged from derailment, release from pipeline, release from tanker, and collision. And in summary, the key preventative measures that were identified from these incidents to limit or manage the risk in future projects includes ensuring that adequate emergency response plans are in place and adhered to, ensuring regular repairs and maintenance schedules for infrastructure and equipment, promoting careful and attentive maneuvering by drivers to avoid human error, ensuring adequate training for personnel, which also covers abnormal conditions, ensuring that safety procedures are understood and followed consistently, and ensuring the correct and secure storage of materials in line with recommendations and regulations. So the Canadian hydrogen and fuel cell sector is recognised as a global leader, and within BC in particular, there are existing opportunities that can support developing hydrogen transportation networks in the province. So firstly, we have favourable policies and sector-specific emission targets that are encouraging hydrogen investment in the province. So for example, the BC carbon tax and the low carbon fuel standard. There's also been significant investment and public sector funding from the BC government and federal government to support hydrogen innovation. In terms of knowledge centre and skilled workforce, BC is home to 51% of Canada's hydrogen and fuel sector organisations. And there has been investment in many projects within the province looking at hydrogen production, which again will drive demand for hydrogen transportation. So for example, the HTEC H2 Gateway project has a total investment estimated at around $900 million. And as mentioned, there's being lots of work done to identify and develop regional hydrogen hubs, and various universities and institutions such as UBC and SFU are contributing to research in the sector. There's also an existing skilled workforce and opportunities for upskilling in the region. So there's an estimated 1,300 employees within the hydrogen sector already, and many other core kind of technical occupations and foundational skills required by the hydrogen economy can be found in other labour markets such as engineering, oil and gas, and petrochemical industries. So there is the opportunity to kind of leverage these existing skills and expand the hydrogen workforce. BC also has existing physical resources and infrastructure that can be leveraged to support hydrogen production and again, demand for hydrogen transportation. So there's an existing supply of low carbon electricity, and BC Hydro is kind of focused on improving and developing the supply within the region to accommodate increased demand. There's also abundant natural gas that can be used to develop blue hydrogen and fresh water and large land masses. And as discussed in the previous slides, BC does have existing transportation infrastructure that can be adapted and upgraded to support hydrogen transportation, with examples of kind of ongoing research and studies to progress feasibility. And then finally, there are many key partnership opportunities with existing and new projects in the region. So this includes partners at a national, provincial and local level. So support for project and initiatives has been received from the Canadian Hydrogen Association and Natural Resources Canada. And as mentioned, regulators such as BCER and other regulatory bodies are kind of playing a key role in facilitating safe and effective production and transportation environments. And there are also opportunities for partnerships with other provinces and in international partnerships. So SEMPO is currently working with Pacific Northwest Economic Region to explore collaboration between BC and Washington State in the hydrogen economy. And finally, there are many opportunities for collaboration with First Nations communities, in particular through the Indigenous Clean Energy Opportunities Initiative. So there are opportunities for kind of joint ventures, shared ownership models, and Indigenous-led projects. And one example is Salish Elements. So they're an Indigenous-owned green hydrogen production company working with partners to develop hydrogen projects and transportation within the province and beyond. So based on the findings from our report, we have developed some recommendations for key parties on strategies to capitalise on opportunities and mitigate risks associated with hydrogen transportation in BC. These recommendations are kind of intended to guide industry, research bodies and regulators. So the first is to capitalise on existing supply chains, innovation and leadership in the hydrogen sector within BC to advance technology and improve efficiencies in hydrogen carrier use and transportation. The second is to support knowledge centres and skilled workforce within the region to improve the cost, efficiencies and availability of technology to support the hydrogenation and dehydrogenation process of carriers. So this could help to enable easier and more affordable transportation of hydrogen via carriers, and also to overcome kind of some of the key challenges mentioned previously with safe and cost-effective transportation of hydrogen. The third is to invest in infrastructure on a case-by-case basis, which aligns with hydrogen demand. So noting that a combination of different transportation methods and carriers would probably be the most kind of resilient and balanced approach. And finally, expand infrastructure in line with the planned hydrogen hubs and active hydrogen projects in BC with good market potential and opportunities. So this ensures that the upfront investment and cost of infrastructure can be offset. In terms of risk mitigation, the first recommendation is to ensure that appropriate and secure storage and transportation of hydrogen and carriers to minimize the harm or severity of consequences and accidents where possible, and in particular undertaking location-specific and project-specific risk assessments to identify and implement management measures. The second is to continue to monitor updated standards and regulations developed for transportation of hydrogen and hydrogen carriers at an international and national level. So adopting kind of best practice where possible within the province. The third is to establish a robust regulatory compliance and incident process for transportation of the carriers and each transportation option, and also adopting lessons learned from the previous incidents as reviewed, and incorporating key processes such as emergency response plans, maintenance schedules, training of personnel, and risk assessments. And finally, undertake further evaluation of transportation options, including dehydrogenation processes versus pure hydrogen delivery infrastructure, to identify the most cost-effective and sustainable options for specific cases, whilst also accounting for variables, as mentioned, such as purpose, distance, and location. So this brings us to the Q&A section. So I think there have been a few questions in the chat, and I'll also introduce our colleague from Sacra Davy, Michelle.
Hello.
And yeah, if there's any additional questions, then feel free to ask them in the chat or the Q&A section. So Peter asks, since social license can be a powerful determinant in many projects, when comparing the different transportation modalities, has there been any investigation into the level of social acceptance for each? So we did kind of review social impacts as part of the assessment, but because it was kind of more general and we were focused on the whole province, I think that would need to be kind of done at a more specific project level. But we do kind of provide an overview of, I guess, the processes that hydrogen projects would need to undergo as part of kind of looking at that social license aspect. The next question is, how much is the carbon intensity and cost of hydrogen transport per kg of hydrogen using these different techniques?
Ashlyn, do you want me to answer that? Not that we have an answer.
Yes.
So this is a complicated issue. We did try to incorporate that into the report, but there's really limited papers out there, and it's a big study. To compare apples to apples, it's very difficult for these things. So we did not include it on the cost or the carbon intensity. It's a very complicated thing, and yeah.
Thanks. Is there any other questions? What method did you find the best of transportation of hydrogen?
And maybe I can take this on. I mean, from a safety perspective, pipeline is definitely generally the safest, but the same thing, it's difficult to put in the infrastructure. And I mean, it's repurposing pipelines is also a challenge. And also you have to look at where it's being produced and where the end user is. Just to let you guys know, the shipping industry is looking at ammonia and they're looking at methanol. And, they're looking at it not just even from transportation, but they're also looking at it as a low carbon opportunity. And methanol is easier to transport. I mean, methanol, I think everybody else has been looking at that, and it's easy to transport. There's existing infrastructure. Ammonia is more challenging with the toxic gas. Like I said, there's no one winner. If there was a winner, I think we would have highlighted that the report, but there's problems with every single one. So we did not do risk assessments on every single carrier. It's, yeah. Hydrogen, you can have vapor cloud explosion, even if it's outside. And then ammonia has a toxic gas. So I don't know if I really answered that, but we did find that there's nothing that's ideal. If it was ideal, I think we would have pointed right to it.
Yeah, definitely. Thanks, Michelle. Yeah, we are definitely able to connect offline, and we will be providing our contact details at the end of the presentation. The next question is, are there active hydrogen transportation projects in BC for each of these techniques that you mentioned?
Active hydrogen transportation projects. I know that the tube trailers are established. They are, there's probably not a lot of them, but a lot of industries are producing hydrogen. That's kind of a new thing. And I've worked on a variety of projects where but they generally just go from point A to point B. They're not doing long distances throughout the province. Similar in Alberta, similar in Quebec and Ontario.
Yeah, in the report as well, we did kind of provide some examples of, I guess, other transportation projects. So, for example, I think there's one in the UK where they're using kind of repurposed oil pipelines for transporting LOHC, but that's kind of not very, I think that's quite a new project and not very standard. The next question is, are there any current projects in BC or Alberta where hydrogen blending has been successfully implemented?
I think ATCO's installed one that's operating up near Edmonton, and I think there's more blending projects throughout Canada, and some are operational. They're still, I think, considered testing, so they are just doing very specific areas. And then they generally don't go past 5% blending. Even though, just as a side note, Hawaii does go higher than 5%.
The next question is, from your perspectives, what is the hardest part about educating the marketplace about hydrogen solutions?
Alicia, I don't know. It's perceptions. So, I mean, even on the liquid organic hydrogen carriers, when people talk about toluene or they talk about ammonia, there's definitely an immediate fear there, even though they do have that in their house. And it is toxic, and it really depends on the quantity, on what the risk is. But yeah, and then hydrogen, compressed hydrogen, it's a compressed gas, so there's danger there. I don't know how to educate the marketplace. Do you have any opinion?
Is Alyssa gonna jump in?
I can just jump in. You know, our team at Foresight, we've done several of these studies now. So if anyone has seen the Lower Mainland Hydrogen Hubs study that we are also doing with BC Sempo, we talk a little bit about, you know, opportunities and you know, dispel common myths. So I would say that there's a level of technical detail with hydrogen solutions that is a difficult concept to understand. And it goes beyond just, you know, sort of baseline understanding. There's a lot of economics and you know, carbon intensity and more technical efficiency considerations that have to be incorporated when evaluating what makes sense to use hydrogen for. So I think communicating that and having people understand that, you know, we can't just say, you know, for example, let's use hydrogen for, you know, home heating and everything will be fine. There's a lot to consider, and there's a lot of factors that indicate whether or not it makes sense from a technical or an economic perspective. And that, I think, is a difficult thing to communicate, but that is hopefully what we're trying to do with this project. So I would encourage everyone to continue following this entire hydrogen project that we're doing with BC Sempo. So there's this transportation of hydrogen study, but there's also regional hydrogen hub studies that we will be releasing. Aislinn mentioned at the beginning of the presentation as well. So I'd encourage everyone to check those out too.
Yeah, thank you. So the next question is, are there ammonia or methanol production facilities in BC? So we did cover this in the report as well. There's Methanex, which is a company in Vancouver, but they don't actually produce methanol in BC. And I don't think ammonia is produced in BC.
I think ammonia is produced
Okay.
intermittently. Methanol, they used to produce it in BC. I think there was a plant in Kitimat, but that's been shut down. But I think Medicine Hat in Alberta is where Methanex produces most of their methanol.
Yeah, and there is, I think Canadian Methanol Corporation is planning to develop a green methanol production facility in BC. So the next question is, in your opinion, how feasible is it that BC will start to transport 100% hydrogen in pipelines? As part of the study, was there an Indigenous consultation to ask if hydrogen pipelines are acceptable? So Michelle, I can pass the phone.
Do you want to answer?
No, you go ahead.
Okay, I don't think, I mean, if there's going to be 100% hydrogen in pipelines, I think it's going to be new pipelines that are going to be very short. I don't think where we are in Canada that it's just impractical to switch natural gas pipelines to hydrogen pipelines. I know there has been some in Europe, very short-term studies that have done that. And I know there's some hopes that we can just convert it, but it's a very complicated thing. We don't have the compressor stations to actually switch and transport hydrogen across, thousands of kilometers. And then you have to do big engineering assessments. So it's not a simple thing. I think practically it's probably not going to happen soon, but they are making 100% hydrogen ready appliances for end users. That is coming to Canada. CSA is looking at that. And right now they're just doing end user appliance testing, but I think they're only testing up to 20% right now. And as part of the study, I'm not sure, I don't think, we didn't really look at 100% hydrogen pipelines as one of the key things here. We did in the report, we mentioned it, but as is consultation, I don't think we looked at that.
Yeah, no, but and there's kind of recommendations in the report as to, I guess, how Indigenous consultation would be included as part of new pipeline or upgrade projects.
I think it's a requirement.
Yeah.
For all pipelines. I mean, pipelines within BC are controlled within BC, but then anything it crosses over provinces, it's a federal thing.
Is there any research done in coating the pipeline for 100% hydrogen transportation in pipelines?
So Europe's been looking at this. I think they look at putting a kind of like a plastic sleeve inside some of the existing pipelines. They've looked at it. There definitely is some literature out there on it. So yeah, I mean, definitely. And it is a way to avoid the hydrogen embrittlement and deal with some maybe potential older pipelines. But I think there's a limitation on like just trying to coat it. It'd have to be a fairly large line, and yeah, it's just not very practical in Canada. Europe's way more condensed than Canada.
Sounds good, thanks. Are there any other questions from the chat or the Q&A? So I guess if there are no further questions, I can just move on to our final slide. So Thank you so much, everyone, for joining today. As mentioned, please stay tuned for our further ongoing BC Hydrogen Hubs work. And this will continue throughout the province and into next year with our Interior BC and Vancouver Island study. So yeah, if you have any other questions or comments, please feel free to get in touch with myself or Alyssa. And thanks again, and we really appreciate your attendance and hope you have a great day.